welcome to this explainer. If you've ever spent days, or let's be real, maybe even weeks, wrestling with broken dependencies just to get a single AI model running on a bare metal server, well, you are definitely going to want to pay attention today. We're diving into a really fascinating technical integration guide from Supermicro. We're going to look at exactly how to transform standard bare metal infrastructure into an active, ready-to-use AI environment. And we'll do it using SuperCloud Composer and RHEL AI. It's honestly a brilliant look at how modern infrastructure provisioning is evolving. I want to start by asking a question that I know pretty much every IT ops and machine learning engineer is facing right now. How do you take a raw, bare metal server and turn it into a fully functioning, hardware-accelerated AI chatbot in just a few steps? I mean, it sounds like something that should take weeks of agonizing configuration, right? Well, that is exactly the problem this guide solves. So, to answer that, let's quickly walk through our agenda for today. We're going to start by unpacking RHEL AI, explore the power of image mode, deploy the OS via SCC, chat a bit with InstructLab, and finally, look at extracting OS tree images. All right, Section 1, Unpacking RHEL AI, the true foundation of AI. So Red Hat Enterprise Linux AI, or RHEL AI for short, isn't just your standard operating system. It's a foundational platform that's purpose-built from the ground up to streamline AI development. Instead of starting from scratch and painstakingly installing dependency after dependency, RHEL AI gives you this massive head start. Literally, right out of the box, you get PyTorch, all your essential runtime libraries, and hardware acceleration for the major GPUs. We're talking NVIDIA, Intel, and AMD. Plus, it includes integrated tools like InstructLab and gives you access to indemnified Granite models. That means enterprise users actually have legal backing when deploying them, which is absolutely crucial. It's basically an entire machine learning ecosystem, neatly bundled into one single bootable image. Moving on to Section 2, the power of image mode and the container native OS. This brings us to image mode for RHEL. Now, the crucial point here is that instead of a traditional install, image mode treats the entire operating system as a bootable container. It's like the ultimate DevOps bridge. By encapsulating all those runtimes, drivers, and dependencies into a container-native approach, your operations teams and developers can finally use the exact same techniques. They can use GitOps and automated CI/CD pipelines to manage the underlying operating system just like they manage their software code. It's a real game changer. Okay, Section 3. Let's look at deploying the OS via SSCC with automated provisioning. The deployment process here requires 3 quick preparatory steps. First, you upload your base server ISO. Second, you script out your automation in a customized answer file, which is often called a kickstart file. And third, you just ensure your target OS tree container image is available in your registry. You can think of that OS tree image as a version-controlled Git-like repository for all your operating system binaries. Let's dive into that first step. The interface is remarkably straightforward. You simply upload the standard RHEL 9.4 ISO directly into your SuperCloud Composer artifacts library. And that's it. That becomes the base we're going to boot from. Next up is the answer file. Instead of agonizingly clicking next through, 50 setup screens, we use a custom kickstart script. This script silently handles all those tedious tasks, formatting file systems, creating users, injecting SSH keys. But most importantly, it tells the system exactly where to fetch that specific NVIDIA-optimized boot container image we talked about a minute ago. So with your artifacts ready, the actual deployment is literally just a few clicks. You select your image and your newly created answer file from the drop-down menus, target your specific bare metal node, like Node 5, for example, hit Submit, and SuperCloud Composer just takes over the entire provisioning process. You can just sit back. And here we see the automation actually doing its thing. The server boots directly from the network via PXE right into the Anaconda installer. It rapidly runs through all of our customized storage labels, disk partitioning, and pre-installation scripts, and it does it without a single manual intervention required. No humans needed. Just moments later, the deployment hits its final stages. It knocks out the post-installation tasks, generates the initram fes, which is that initial temporary file system loaded into memory, and boom, completes the setup. The system is now fully configured and ready to host its very first real AI workload. All right, Section 4, chatting with InstructLab and running local large language models. Before we can actually start chatting, we do have a tiny bit of housekeeping. The very first time you initialize the iLab command line tool on the host, you have to authenticate the machine. You just connect the host using your Red Hat organization ID and an activation key, which syncs it up with Red Hat Insights. Once you're authenticated, initializing InstructLab is incredibly streamlined. The automation really does the heavy lifting here. You run ilab config init, and it prompts you to select your hardware profile. For instance, maybe you're running an 8-way NVIDIA A100 setup. You select that, then export your Hugging Face token to the environment and command it to pull down your foundational model. Let's see what that actually looks like. Once everything is downloaded, running an alab model list command confirms that the IBM Granite 7B base model is locked, loaded, and ready to serve on your infrastructure. And remember, that model is fully indemnified by Red Hat, and it sits at about 25.1 gigabytes. Now let's see how this builds into an active service. By running the ilab model serve command, it spins up the backend API. What's absolutely fantastic here is the visibility. The terminal outputs real-time metrics showing prompt throughput, active running requests, and, maybe most importantly, zero memory swaps. That confirms the hardware acceleration is actively engaging with the model without any bottlenecking whatsoever. And here is our ultimate payoff. By executing ilab model chat, we get a live, responsive AI assistant. We can query geopolitical and geographical data about Taiwan, which perfectly demonstrates the local model's ability to process complex prompts and generate text right from our newly configured bare metal hardware. I mean, we've gone from an empty server to a live AI chatbot. How cool is that? Finally, Section 5, extracting OS tree images and containerizing the OS. If you ever find yourself needing to manually extract the OS tree container image that Red Hat built, the process is super straightforward. You just mount the RHEL AI ISO locally and then use the Scopio copy command line tool. This lets you smoothly push that container image out to literally any TLS-enabled registry of your choosing, making it super accessible for all your deployment pipelines. We've definitely covered a massive amount of ground today, seeing exactly how perfectly SuperCloud Composer integrates with RHEL AI. So the crucial takeaway from this explainer is really this. With bare metal OS deployment and hardware-accelerated AI model serving reduced to just a few simple Composer commands and automation scripts, what is actually limiting your AI innovation now? When the infrastructure gets out of your way this efficiently, the only boundary left is your imagination. Thanks so much for joining me today, and keep exploring.